Welcome to Astronomy Daily, the podcast that brings you the universe one story at a time. I'm Avery.
And I'm Anna. It's great to be with you. Today, we've got news of a surprising discovery about one of Saturn's most famous moons, to a cosmic crash that's rewriting our understanding of planet formation.
Plus, we'll be talking again about our interstellar visitor, a mishap with the Starlink satellites, and NASA's incredible new map of the cosmos. So where are we starting, Anna?
We're heading out to the Saturn system, specifically to its largest moon, Titan. For years, scientists have been excited by the theory that beneath Titan's icy crust lies a vast liquid water ocean, making it a prime candidate for extraterrestrial life.
Right, the hidden ocean theory. It's been a cornerstone of astrobiology discussions for a while.
Exactly, but a new study reanalyzing data from the Cassini mission is challenging that picture. It suggests Titan's interior might not be a liquid ocean after all. Instead, it could be a thick, warm, and slowly freezing slush.
Slush? So less of a swimming pool and more of a cosmic snow cone. What does that mean?
Well, the data points to high-pressure ice layers forming deep inside, which can trap liquid. So instead of one big interior ocean, we might be looking at smaller, isolated pockets of meltwater within a mostly solid icy mantle. It complicates the idea of a single habitable environment.
That's a major shift in thinking. Does it lower the chances of finding life there?
It makes it more challenging. A large, stable ocean allows for the free movement of nutrients and potential life. Small, isolated pockets are less dynamic. It doesn't rule life out, but it definitely changes where and how we would look for it. It's a fantastic reminder that our assumptions are always being tested by new data.
Absolutely. From the far reaches of the solar system, let's come a little closer to home for our next story. It involves SpaceX's Starlink constellation, which had a bit of a hiccup recently.
I saw the headlines on this. What happened?
One of their satellites experienced what they're calling an anomaly. It essentially broke apart, creating a small amount of trackable debris and, of course, cutting off communication with the satellite itself.
Space debris is always a concern. Is this a major risk to other satellites?
Fortunately, in this case, the risk is very low. SpaceX has confirmed that the satellite is in a very low orbit and is expected to completely deorbit and burn up in Earth's atmosphere within a few weeks. So it's a self-cleaning problem, which is good news.
That's a relief, but it does highlight the growing debate around these massive satellite mega-constellations and the long-term sustainability of low Earth orbit. One anomaly is manageable, but thousands of satellites increase the odds of future problems.
And the numbers are truly staggering. We're not talking about hundreds of satellites anymore, but tens of thousands planned for launch in the coming years. It raises the specter of the Kessler syndrome, doesn't it? Where the density of objects becomes so high that collisions create a cascading chain reaction of debris.
It absolutely does. That's the nightmare scenario for space agencies. A runaway cascade could render certain orbits unusable for generations. That's why international cooperation on space traffic management and debris mitigation is becoming so critical. It's not just about protecting individual assets anymore. It's about preserving access to space for everyone.
Precisely. The technology is incredible, but the responsibility that comes with it is equally immense, a crucial topic for our times.
So it's less about a single failure and more about the cumulative risk of having so much hardware orbiting above us. It's a delicate balance between enabling global connectivity and creating a long-term environmental problem right on our cosmic doorstep.
That's the bigger conversation for sure. It's a test case for how companies manage their orbital footprint. Speaking of managing space, our next topic shifts from the corporate to the governmental. Anna, you're taking us into the world of space policy.
That's right. President Trump issued an executive order that significantly reorganized national space policy. The headline-grabbing goal set by the order was a 2028 landing for astronauts on the moon.
2028. That's an incredibly ambitious timeline, even more aggressive than NASA's own initial plans.
Extremely. The order was designed to accelerate things, reinforcing NASA's Artemis program, which is the framework for that lunar return. Beyond the moon landing, the order also called for a comprehensive space security strategy, addressing the increasing militarization and competition in space.
That makes sense. It's about planting a flag, both literally on the moon and figuratively in terms of geopolitical standing. Did the order have lasting effects?
It certainly solidified the Artemis program's direction and injected a sense of urgency. While the 2028 timeline has since been adjusted to be more realistic, the core focus on a sustainable lunar presence and preparing for Mars remains central to U.S. space policy. It really framed the narrative for this decade of space exploration.
It's fascinating how policy can shape science on such a grand scale. And from grand policy to a grand cosmic mystery, our next story feels like a detective novel set in space. We're talking about the exoplanet Fomalhaut B.
The zombie planet. I love this story. It was one of the first exoplanets to be directly imaged, but it behaved so strangely over the years.
Exactly. It was dimming and had a weird orbit. Well, astronomers using the Hubble Space Telescope finally cracked the case. Fomalhaut B was never a planet. What they had been tracking was the expanding cloud of debris from a massive cosmic crash between two large icy bodies.
So they were literally watching the dust settle from a collision. That's incredible.
It gets even better. They realized that they had also witnessed a second, more recent collision in the same system. This means we're getting a rare, real-time look at how planetary systems are built through violent, chaotic collisions. We're not just finding planets, we're watching the construction zone.
It really is a construction zone, and a messy one at that. What kind of scale are we talking about for these colliding objects? Are these planet-sized bodies?
Based on the models, they estimate the objects were both around 200 kilometers in diameter, so large asteroids or protoplanets. The impact would have been catastrophic, vaporizing them and creating an expanding cloud of extremely fine dust particles, smaller than grains of sand. That's what Hubble was actually seeing.
And that dust cloud is what tricked everyone into thinking it was a planet for so long. It was bright enough to be seen, but as the cloud expanded and dispersed, the object appeared to dim and eventually fade away, which is not something a planet does.
Exactly. It's a perfect example of the scientific process in action. An observation, a hypothesis, it's a planet, and then more observations that don't fit, leading to a completely new and even more exciting conclusion. The universe is full of surprises, and sometimes a disappearing act is more interesting than a discovery.
That gives you such a sense of perspective. It's a reminder of the dynamic and sometimes destructive processes that shaped our own solar system billions of years ago. What a discovery. And speaking of things passing through, our next story is about a visitor that won't be staying.
Right, an interstellar traveler.
Indeed, the Interstellar Comet 3I Atlas is currently making its closest approach to Earth. This is an object that was born in another solar system and has been traveling through the galaxy for millions, maybe billions of years before wandering into our neighborhood.
Can we see it? Is this another naked eye comet opportunity?
Unfortunately, no. It's far too faint for the naked eye or even backyard telescopes. But for those who want to follow its journey, there are numerous online tools and observatories providing tracking data and even live streams as it makes its flyby.
So we can still watch it, just digitally. And this is a one-time show, right?
Correct. Its trajectory is hyperbolic, meaning it has more than enough speed to escape the sun's gravity. Once it passes us, it's heading back out into interstellar space, never to return. It's a fleeting chance for scientists to study a pristine sample from another star system.
Incredible. It's like a cosmic postcard from a place we'll never visit. For our final story, we're zooming out from a single object to look at the entire sky, thanks to a new NASA mission.
This is about the SpaceX telescope, right?
That's the one. The SpaceX Space Telescope has just completed its first all-sky infrared map. This isn't just a picture. It's a map taken in 102 different colors of infrared light. Think of it as giving us a new set of eyes to see the universe's heat signature in unprecedented detail.
And what will scientists do with that data? What questions can this map help answer?
It's going to tackle some of the biggest questions in cosmology. First, by looking at the large-scale structure of the universe, it will help us study the rapid expansion period right after the Big Bang. Second, it will map how galaxies have formed and evolved over cosmic time.
That alone is huge.
It is. And third, and perhaps most excitingly for many, it will map the distribution of water and organic molecules, the key ingredients for life, throughout our galaxy's stellar nurseries and planet-forming disks. This map will be a foundational resource for astronomers for decades.
From the origins of the universe to the origins of life. That's an incredible scope, a perfect big picture story to end on.
And that's a wrap for today's episode. We've gone from a slushy moon to a phantom planet and all the way out to an interstellar visitor.
Thanks for joining us on Astronomy Daily. You can find us on all major podcast platforms, and our DMs are always open for questions and future show ideas.
We'll be back next time with more news from across the cosmos. Until then, keep looking up.